LPV stands for Localizer Performance with Vertical Guidance. LPV is a category of approach minimums for RNAV approaches that are typically lower than LNAV or LNAV-VNAV minimums. RNAV approaches with LPV minimums are built on the Satellite-Based Augmentation System, or SBAS. In the United States and Canada, this system is known as the Wide Area Augmentation System, or WAAS. Other SBAS systems currently operating or in development at this time are the European Geostationary Navigation Overlay Service, or EGNOS, GPS-Aided Geostationary Augmented Navigation, or GAGON, and the Multifunctional Satellite Augmentation System, or MSAS. Additional SBAS systems have been proposed for future development. An SBAS system is typically made up of a network of ground-based sensors along with space-based communication satellites and SBAS-capable GPS receivers. The ground-based sensors gather GPS signals and apply a correction to them. The correction data is then sent to a communication satellite, which in turn broadcasts the information to an SBAS-equipped GPS receiver on board an aircraft. The GPS receiver combines the SBAS correction signals with data from GPS satellites and produces highly accurate position data that is then used to fly RNAV approaches to LPV minimums. Prior to the development of SBAS, GPS was not able to provide the accuracy or integrity to achieve Cat 1 minimums during approaches. The FAA and Department of Transportation began development of WAAS in 1994 to allow precision approaches, and in 2003, WAAS was activated for public use. An RNAV approach with LPV minimums combines the FMS navigation database with SBAS signals from GPS satellites to produce an approach that closely mimics an ILS. FMS navigation databases and SBAS-capable aircraft contain an additional piece of information for each LPV approach called a Final Approach Segment, or FAS, data block. The FAS data block contains the lateral and vertical parameters that define the approach to be flown. An RNAV approach with LPV minimums combines information from the FAS data block with highly accurate SBAS correction signals to produce an approach that closely mimics an ILS. This increased accuracy allows LPV approach minimums to be as low as 200 feet and 1/2 mile visibility. Similar to an ILS, when LPV is active on an approach, course deviations are angular instead of linear, meaning the sensitivity of the deviations are increased as the aircraft approaches the runway. To explain further, on an approach using linear deviation, a 1 dot deviation can equal 75 feet at the final approach fix and 75 feet at the runway, whereas on an approach using angular deviation, a 1 dot deviation can be equal to approximately 180 feet at the final approach fix, but only 36 feet at minimums. On Gulfstream G4 and G5 aircraft, RNAV approaches to LPV minimums are conducted using nav source guidance and the LPV enable button. When the LPV enable button is activated, the localizer and glide slope deviation indications are not received from the nav radio, but directly from the SBAS-enabled GPS. RNAV approaches cannot be flown to LPV minimums using FMS source guidance. Let's walk through an operational example of an approach to LPV minimums. First, select the appropriate runway. Then select the desired RNAV approach. Select the approach transition. When selecting an RNAV approach with LPV minimums, LPV is the default minimums selection. Select Activate to load the approach into the flight plan. Each RNAV approach with LPV minimums is identified by a unique approach identifier or approach ID. The pilot must verify that the approach ID on the approach chart matches the approach ID on the arrival page. This verifies that the correct FAS data block is loaded in the FMS. Push the LPV enable button and verify that On is displayed in green. On the display controller, select the nav preview mode and dial in the final approach course using the course selector knob. When cleared for the approach, push the approach button on the guidance panel to arm the approach. When the approach is armed, Localizer and Glide Slope are displayed as the armed submodes. When the preview mode is activated and the approach button is pushed, the automatic transition feature will transition the flight guidance system from long-range navigation to short-range navigation as the aircraft approaches the final approach segment. This enables the pilot to fly the first part of the approach using FMS long-range navigation and the final part of the approach using short-range navigation without manually changing modes. The lateral course and vertical glide path during an RNAV LPV approach are captured similar to an ILS localizer and glide slope. As with an ILS approach, the glide slope mode during an approach to LPV minimums ignores the altitude preselector, enabling the pilot to set the missed approached altitude. It is important to remember that the aircraft will not level off at the decision altitude. As the aircraft reaches the LPV decision altitude, the pilot must either continue to land or initiate a missed approach. Pushing the toga button will activate the go-around mode, and the remainder of the missed approach is flown using FMS source guidance. When conducting SBAS operations, there are a few important things to remember. LP minimums on RNAV approaches stands for Localizer Performance without vertical guidance. Currently, operators of Honeywell platforms are not authorized to perform approaches to LP minimums. Pilots must be familiar with the fail-down capabilities of their SBAS system. A red X is displayed on the vertical deviation scale when conditions exist that would prohibit descending to LPV minimums, such as an SBAS failure. If a red X is displayed on the vertical deviation scale, the flight crew may have the ability to continue the approach to LNAV-only minimums. This is similar to losing glide slope deviations on an ILS approach and continuing to localizer-only minimums. Refer to AC90-107 or AMC20-28 and the manufacturer's guidance for further information on SBAS fail-down procedures. Pilots must notify air traffic control of any loss of GPS or SBAS capability and state their proposed course of action. RNAV approaches with LPV minimums, together with SBAS systems, provide an efficient alternative to traditional ILS approaches. This video has been an overview of LPV. Please be sure to refer to AC90-107 or AMC20-28 and the Aircraft Flight Manual for more detailed information.